Let's take a look at number 7. Number 7 says a 1 kilogram ball is thrown into the air with an initial velocity of 30 meters per second. How much kinetic energy will it have? Part B, how much potential energy will it have when it reaches the highest point? And part C, how high did it travel? Okay, so we had a 1 kilogram ball moving 30 meters per second. Let's note our given information. 30 meters per second is the speed. 1 kilogram is the mass. Now, what are we looking for here? Well, in part A, we're looking for kinetic energy. Part B, we're looking for potential energy. And part C, we're looking for the height at the highest point. So to do this, we're going to need the following equations. We need kinetic energy is equal to 1/2 mass times velocity squared. And we need potential energy is equal to m times g times h. Let's go ahead and split up these parts into their own boxes. And for part A, we're going to start with our kinetic energy equation, 1/2 mv squared, plug into that. We have 1/2 times the mass of 1 kilogram times the speed of 30 meters per second squared. Well, ladies and gentlemen, start with your speed and square it. Now 30 squared, go 30 squared, then multiply that times 1, then take 1/2. I'll give you a second to try and practice that yourself. You should have gotten 450 joules of kinetic energy. Part B, we want to know the potential energy at the top. So this is the kinetic energy at the bottom. Well, to find the potential energy at the top, we need to know that the kinetic energy at the bottom transforms into potential energy at the top. That is a sentence and a statement we're going to develop a little more in depth this week. This means the kinetic energy at the bottom equals the potential energy at the top, which equals 450 joules. So the 450 joules of kinetic energy we found in part A is also the potential energy found in part B. And then finally in part C, to find the height, well, let's use the potential energy equation now that we have it and use that and solve for the height. We're going to need to divide by mg to get h by itself. And the height would be 450 joules of potential energy divided by 1, which is the mass, times 10, which is g. So it's 450 divided by 10. Give you a second to put that in your calculator. Should end up with 45 meters high. Let's take a look at number 8. What is the potential energy of a 3 kilogram ball lying on the ground? So we're looking for potential energy. We were told that it was a 3 kilogram ball. G is always known to us, but we're told about the ground. the ground would be an indication of height equals 0 meters. So what does this tell us? If we use our equation, 3 kilograms times 10, I should round that up to 10, times 0 equals 0. Potential energy at the lowest point, well, that equals 0.